Well, welcome to HCC Math, brought to you by Quarantine Isolation. So today we're going to actually finish where we left off, which we had done some rational expressions is where we had taken our test. We have simplified rational expressions, multiplied rational expressions, divided rational expressions, added and subtracted rational expressions. Oh, excuse me. But today we're going to start solving rational equations. So just an FYI, we're going to start here. And I don't have my slate from school or anything. So it's just going to be me and the mouse pad. So please bear with me. So it says here to first solve the quadratic equation. So I hope that before you started watching the video, you tried to do these. If you didn't, please stop the video and try these practice problems and then come back and check it. So the first thing you could do here is you could solve this using the quadratic formula. You could solve it by graphing, or you could solve it by factoring. Many of you know now I'm a big factorer. So I'm going to factor this. I know factors of 2 times negative 1 are negative 2. So I've got 2x squared minus 2x plus x, because the negative 2x and the positive 1x will give me this negative 1, minus 1. And so when I solve that, I'm going to solve that by grouping. So when I solve it by grouping, I'm going to group these first two together and group the second two together. So what I notice is that the first two both have a 2x, so I take out my 2x. And when I take out the 2x, that leaves me with x minus 1. Now in the second set of parentheses, there isn't a GCF other than 1, so I'm going to do like Billy, and I'm going to put the 1 there, just so that I remember it's there, and that's going to leave me with x minus 1 again. Oh, I got the wrong red. Oh well, that's what happens when I try to be high-tech, and I'm not. So that's an x minus 1. So then when I finish my factoring by grouping, I have 2x plus 1 times x minus 1 and that equals 0. So then when I set my equations equal to 0, my expressions equal to 0, 2x plus 1 equals 0. And x minus 1 equals 0. So this means that x is, subtract 1, so that's a negative 1/2, negative 1 for 2x. So that means that x is negative 1/2. And then we add 1 here, and that means that x is positive 1. So there's our two answers. And we can always check them by typing in our calculator and seeing if it works. Okay? So our next problem said to add. So in order to add, we have to have a common denominator. So to get a common denominator, the first thing we need to do is factor. Since this has an x minus 2, I'm pretty confident that this is going to have an x minus 2. So I'm going to factor that, and it's going to be x minus 2. And then what times negative 2 gives me positive 2, and that's negative 1. So this needs a negative 1. So now to get them to be the same, we compare our denominators. What does the first one have that the second one doesn't? Well, the first one has an x minus 1. So we're going to multiply the numerator and the denominator by x minus 1, because when you do that, You can't just multiply the top by 1 and the bottom by 1, otherwise you have a big booty and no top. So you want to make sure you multiply top and bottom by the same thing. So now we have the same common denominator of x minus 2 and x minus 1. And life is pretty easy on this problem. They did it pretty easy for us because they said 1 times that. So our numerator is going to be 5 plus x minus 1, because 1 times x is 1, 1 times negative 1 is negative 1. And our denominator is going to be x minus 2 and x minus 1. So then when we combine like terms, oh, I don't like how that x looks. That's a little bit bigger. So we combine like terms. On the top we have, in the numerator we have x plus 4. And in the denominator we have x minus 2 and x minus 1. We look to see if anything can cancel. And nothing can cancel because we can't factor the numerator any further. But we might think to ourselves, hey, since this is a rational expression, when would my denominator be 0? Well, your denominator would be 0 when these would equal 0. So x equals 2 and x equals 1 would be when it's undefined. That wasn't the question. All we had to do was simplify. So all you had to do was get to there. Then for number 3, we're multiplying. So in order to multiply this, what we're going to do is we are going to see what we can factor. Well, 9x minus 5 doesn't factor, so that just stays. That's a pretty good looking 9. Got a little cocky, so my x is a little gross looking. 9x plus 5 divided by 15 times, we got our 5x. And then our denominator, that's a difference of 2 squares, a perfect square minus a perfect square. So that's a 9x plus 5 and a 9x minus 5. So, can we cancel anything? So when we're looking for things to cancel, in order to cancel they have to be factors, which means they have to be multiplied together. So we can cancel this 9x plus 5, because Billy would tell us that that's really 9x plus 5 times 1. So we write that 1 there, and then that cancels this, and that leaves a 1. And then 15 and 5x. Well, 5 divides into 15 thrice. Is there anything else we can cancel? No. So we can write our denominator, or write our final solution. 1 times x is just x. And then our denominator is 3 times 9x minus 5. Now if you want to show off and be like, I can multiply that, you can multiply that. You can make it 27x minus 15. That's fine. Most people would just leave it as it is in factored form, because lots of times, when you multiply rational expressions, you're doing so and then you're going to multiply them by something else. So you may have more multiplication that has to be done. So just a little something there. Okay? So our objective today is that you will use factoring in order to solve rational equations. Yeah, we're going to use factoring. Factoring is not going to go away. So if you're one of those people that doesn't like factoring, you might want to go back and look back at your notes. Go to Khan Academy, see if you can find some factoring problems. So we're going to use factoring in order to solve a rational equation. So what's a rational equation? Well, a rational equation is any equation that contains one or more rational expressions. So a rational expression is a fraction that has a variable in it. One of the things we have to be careful of is these rational expressions is when the variable is in the denominator. That's always something we've been cautious of. To solve a rational expression, our first step is to factor all of the algebraic expressions. So if it can be factored, you're going to factor it. Once that's done, we want to find the least common denominator. Now, if you've factored your algebraic expressions and you notice within the rational expression you can reduce, simplify it. Makes your life easier in the end. If you don't notice, it's not a big deal. It's not going to screw you up or anything. Okay. Oh, I'm so sorry for yawning. This working from home. Wow. Determine the least common denominator. Once you have your least common denominators, you're going to multiply both sides of the equation by the LCD. I did say multiply, so we're going to multiply both sides of the equation by the least common denominator. When you do that, what happens is the denominators cancel. And so once the denominators have canceled, then what you're going to do is solve the rest of the equation. So when we solve the rest of the equation, we have to check our answer for extraneous solutions. So that's one of my favorite math words, extraneous and asymptote. Love those two. Extraneous means extra solutions. So in other words, is there a solution that comes up because we multiplied by something that had a variable in it? So you basically just have to check your solutions. Okay? So let's try one. Nope, let's take some more note. Extraneous solutions. I'll let you watch that because I know that's kind of cool. Are any solutions to a rational equation that is a solution that when replaced into the original equation results in a 0 in the denominator, aka when a solution is an excluded value. So remember at the beginning when we started doing rational expressions, we talked about where would the denominator be 0, and we called those excluded values. So if we look at our excluded values in the beginning, and we say, okay, we can't have these as our answers, and we get one of those as an answer, we know it's an extraneous solution. All right, so taking a look at this first set here. So we have two equations on the screen. We're going to take a look at number 1. So in order to do this, first, we have to factor. Is there anything to factor? Very good. There's nothing to factor. Number 2 is we need to find a least common denominator. Well, our denominators are 2, 3, and 6. So if I count by 2's, and I count by 3's, and I count by 6's, the smallest number in all 3 is 6. So what I'm going to do is multiply both sides of my equation by 6. So I'm going to write this out. Okay, so basically I have 6x divided by 2 plus 6 times 8 divided by 3 equals 6 times 1 divided by 6. So what happens then is, okay, now I'm trying to simplify. What is 6 divided by 2? Well, 6 divided by 2 is 3x. So when I do the same thing here, 6 divided by 3 is 2. 2 times 8 is 16. Equals 6 divided by 6 is 1. And 1 times 1 is 1. So then we solve that little equation. So we subtract 16 from both sides, so 3x equals negative 15. And we divide both sides by 3. So x is negative 5. And so then you can take it into your calculator. So you can take it into your calculator, and when you type it in your calculator, you've got 5 divided by 2 plus 8 divided by 3. So that's all I did was I typed that into my calculator. Okay. Oh, it helps if I type in the right thing. 5 divided by 2 plus 8 divided by 3. Let me go back to the question. Oh, and it helps if I type in the right number. So it's negative 5 divided by 2 plus 8 divided by 3. And that right there, if I make it a fraction, I do math, enter, enter. And that's 1/6, and that's what I wanted it to equal. So that's how I checked my answer. Okay? I know. You wished I had my Chinese earbuds in, don't you? Kind of got rid of them because, yeah, they didn't really work. All right, so we're going to do the same thing over here. We need to count by 2, we need to count by 9, we need to count by 18s until we find a number that's in all three lists. You use the smallest number. In this case, it's 18. So we're going to multiply everything by 18. Okay, so again, I'm going to show my work. So I'm going to take 18 times t. Now, if you don't like using a t because it looks like a plus sign, you can switch your letters to x. That's not a problem. So I have 18 times the quantity of t minus 4 divided by 2 minus 18 times the quantity of t minus 3 divided by 9 equals 18 times 5 divided by 18. So here's the beautiful part. What's 18 divided by 2? 9. So we have 9 times the quantity of t minus 4 minus, what's 18 divided by 9? 2 times the quantity of t minus 3 equals 18 divided by 18, which is 5. And now there's nothing new here. All we have to do is solve our equation. So when we solve our equation, 9 times t is 9t minus 36 minus 2t plus 6 equals 35. Do you already see how it's going to work out? 9t minus 2t is 7t. Negative 36 plus 6 is a negative 30. Oops, look. I saw it already working out. So I had already put 35 here instead of just 5. Equals 5. Then I add 30 to both sides. So 7t equals 35. And so t would equal 5. So t minus 5 is 1. So that's 1/2. And that's minus 5 minus 3 is 2, so that's 2/9. Okay, and if we type that in our calculator, 1/2 minus 2/9, we get this decimal. And if I type in 5 divided by 18, helps if I press enter, they're the same. So that was another check. Okay? Oh, Finny, you're killing me here. Oh, Finny, you're killing me there. Finny, what are you trying to do to me? Finny. I know. I know. So when we look at number 3, it's really not too bad. Because when you look at number 3, you see that we have 4 terms. The first is 3 over 1. The second is 6 over x. The third is x over 1. And the fourth is 8 over 1. So what's our common denominator? Well, our denominator is 1 and x. So our common denominator is x. So we're going to multiply both sides by x. So when we do that, we've got 3 times x, which is 3x, minus 6 times x divided by x. So that's just going to give us 6, right? Because these x's canceled, equals x times x, which is x squared, plus 8 times x, which is 8x. So we're going to have a quadratic this time. I'm going to bring everything over to the right so that it's positive. So I'm going to have 0 equals x squared. 8x minus 3x is 5x. And plus 6. Now before I go any further, I'm going to go back up here and I'm going to ask you, when will this situation be undefined? So what's a variable, value for the variable that we can't use? So what can't x be? Well, remember we can't divide by 0, and that's the only thing in our denominator. So x can't be 0. So if we get 0, we have an extraneous solution. We have to factor this. Some of you might want a quadratic formula, some of you might want to graph it. I already know that the answer is x plus 3 and x plus 2, because factors of 6 are 3 and 2. And you may be saying to yourself, Finney, I miss you. Or you may be saying to yourself, Finney, why can't we use 6 and 1? Well, that's a good question. So the reason you can't use 6 and 1 is because we're adding. Since this is a plus, we want our terms to be added together to equal 5. And 6 plus 1 is 7. Can't do that. So now we have these, so we set each of these equal to 0. So x plus 3 equals 0. So that means that x is negative 3. And over here we have x plus 2 equals 0. So that means that x equals negative 2. Now, you can go up to your calculator again, and we have 3 minus 6 divided by x. So if I go up to my calculator again, and I have 3 minus 6 divided by negative 3, I got 5. And then the other side of that equation was x plus 5, x plus 8. So negative 3 plus 8, which is also 5. So now if I do negative 2 plus 8 on the right side, I get 6. And if I do 3 minus 6 divided by negative 2, I also get 6. So there's my work for those last two. So you can see they both equal 6. Okay? Alrighty. So are you seeing what we're doing here? Are you picking up what I'm putting down? Hey, what do you call bears with no ears? Bears with no ears. Bees. Okay, so now we're going to take a look at our next problem. So we're going to get busy, like little bees. All right, so for real. So what we have to do now is we have to factor. So let's look first off, are there any undefined moments here? Well, of course there's an undefined moment. X can't be positive 5 because positive 5 minus 5 would be 0. So x can't be positive 5. The other thing x can't be is negative 5 because x plus 5 would be 0 if x was negative 5. So now what we have to do is we have to factor x squared minus 25. So who remembers how to factor x squared minus 25? I'm waiting. Oh, okay. So it's x plus 5 and x minus 5. So if we're looking for a common denominator, our common denominator would be this, right? Because this has x plus 5 and it has x minus 5. So if we were going to give it to this, we would give this x plus 5 and we would give this x minus 5. So what we're going to do is we're going to multiply this side by x plus 5, x minus 5, and this side by x plus 5, x minus 5. So we multiply this by x plus 5 times x minus 5. And we multiply this side by the same thing. Okay? So that means we're going to have 4x times x plus 5, x minus 5. Now some of you already know that that x plus 5 and that x minus 5 are going to cancel with the x plus 5 and the x minus 5 in the denominator. Some of you are like, I don't even know what I'm writing. Okay, so for those of you that know, hey, I can see right now these two cancel out, you're going straight down here and you're writing 4x. Okay, plus this, we're going to have 2 times x plus 5, x minus 5. And the same people that saw it on the first one are probably the same people that are seeing it here. And they're like, I already know. Then I got that future vision. Me and Michael J. Fox, we're going back to the future. And I can see that these x minus 5s are going to cancel. So they're going straight down here, and they're writing 2 times the quantity of x plus 5. And then equals, and then there's the rest of us who know that 1 times x plus 5, x minus 5 is 1 times x plus 5 is 1x plus 5, and x minus 5. And again, remember, Billy likes to put those 1s in there. That little crazy white boy. Love that Billy. Okay, and so Billy is probably one of those people that says, oh, I see it. I see that that x plus 5s are going to cancel there. And that's going to leave me with just a straight up 1 times x plus 5, or excuse me, x minus 5. Now, for those of you that are back here with me, if we go back and we look here, what do these, how did we get from here to here? Well, remember, we're simplifying. So the x plus 5's canceled, the x minus 5's canceled. The x minus 5's canceled. The x plus 5's canceled. And when those are gone, right, when that's all gone, you have 4x. When this is all gone, you have 2 times x plus 5. When this is all gone, you have 1 times x plus x minus 5. And then all you have to do now is solve that little equation. Okay, so we've got 4x plus 2x plus 10 equals x minus 5. Why did I write 6? Oh, I know. You told me, Sean, didn't you? I know you did. You probably did too, Diamond A. I'm sorry. I just wasn't listening. I'm listening now, baby. I'm listening now. Okay, so 4x plus 2x is 6x plus 10 equals x minus 5. And we're solving equations. So we're going to get all of our x's on one side. So we have 5x equals 10. I'm sorry, 5s. Plus 10. equals negative 5. Then we'd subtract the 10, so we'd have 5x equals negative 15. And so that would mean that x would be negative 15 divided by 5, which would be negative 3. Negative 3 is not one of our numbers up here, showing as an excluded value, so we should be good if we checked it. Okay, so I've got 4x, which is negative 12, and then 9 minus 25 is negative 16, so I have negative 12 divided by negative 16 plus 2 divided by negative 3 minus 5 is negative 8, and that equals 1/2, and negative 3 plus 5 is 2. Beautiful. Works out. Okay? All right, what's our common denominator? Good. What are our excluded values? Exactly. X cannot be positive 4. Because if x is positive 4, then that means we have zeros in our denominator. So what we're going to do is multiply everything by our common denominator, which somebody told me. It's probably Anthony. You know how he is. Always yelling the right answers. So our x minus 4 times 2x divided by x minus 4 is going to give us 2x equals 8 times x minus 4 divided by x minus 4 is going to give us 8 plus, there's no denominator here, so we're just going to have 1, because Billy likes to write the ones, x minus 4. Hope you're watching, Billy. You're getting a lot of shout-outs today. Okay, so now we solve this equation. So we have 2x equals 8 plus x minus 4. So now we have 2x equals x plus 4. And when we subtract x from both sides, we find that x equals 4. Finn? Yeah? Yeah, Alexa? It doesn't work. Right, because if we put in 4 in, we have the 0 in the denominator. So since this can't be a solution, there is no solution. So when you're doing this on a test or a quiz, there is no solution here. Okay? Because the only value we couldn't use was 4, and that's the only answer we got. Good job noticing that, Alexa. You too. Shania, I know, I saw you. I heard you. Yeah, Brooke, we heard you too. I know. Mike, I got you. All right. What can't we use here? What can't our x be? Well, x cannot be 2. So if we get 2 for our answer, we can't use it. Okay? So our denominator, this is really x over 1, and this is 1 over 1. So our denominator that we're going to multiply everything by is x minus 2 on both sides of the equation. Multiply this by x minus 2. Multiply this by x minus 2. So x minus 2 times x is x squared minus 2x. The x minus 2's cancel, so that gives me plus 14. equals 7x divided by x minus 2 times x minus 2. The x minus 2's cancel, so that gives me 7x plus 1 times x minus 2, and that's just going to be x minus 2. Combine like terms. On the left side, we've still got x squared minus 2x plus 14. On the right side, we have 8x minus 2. So, subtract 8 from both sides and add 2 to both sides. So we now have a mistake. Oh, there it is. So I now have x squared. Negative 2 minus 8 is negative 10. And 14 plus 2 is 16 equals 0. And I solve. Factors of 16 are 8 and 2. I want a negative 10, so that's going to be x minus 8 and x minus 2. Equals 0. And then we set each of those equal to 0. So we get x could be 8. And we get x could be 2. Yes, you're right. We can't use 2 because that's one of our excluded values. So our only answer is 8. Okay? So, what I'm going to ask you to do is not these practice problems, but if you'll look at It's Learning, there's another set of practice problems on there that I'd like for you to try. I think there's only 6 of them. So I'm going to ask you to try those 6, and when you click on It's Learning, it'll pop up, and then you can solve them, and then there's going to be a check where you can check your answers. You just type in what your answer is for number 1, and then it'll tell you if you're right or wrong. Okay? Thanks so much.